In this video, I will discuss about how to write an ALP for enabling a serial communication using a DB assembler directive. DB is basically used to write a string in the assembly language program. So it's called a define byte. So I divided this program into several parts, and the details are given here as labels here. So this is the starting part. So I called as a main program. And here I have another part of the program, which is called again. And this is continuation or continue. So to mark it, I have another label here. Then here I have a subroutine, transfer subroutine over here. And there is another space required here. So I given one label here called my var. So now here my intention is to communicate serially the string serial communication. Okay. So what do I have to do first? First, I have to set up my serial communication. So this is what happens from the main program, start up the main program. So here we prepare the serial communication for 8-bit and 1 stop bit. And here we use the TMOD to set the baud rate, and the TH1 we configured with the value -3, that is to set 9600 baud rate. And once we do this, then what we do, we start our timer. So as we start the timer, the baud rate would be continually getting generated here. And now here, when you see that it is, we are using, since we are using a DB, so I have a complete part over here. Before that, I wanted to come from the line number 21. In the line number 21, what do I have? I have written another assembler directive called org 300h, 300h. Here also we have org. Line number 2 and line number 4 also we have org. This is org 00h and this is org 30h. We start from 00h, but we bypass from 00h and we move to 30h. That's what it means. But now here, what do? We wanted to use some part of the memory. So I start from org 300h. So what do I do basically? Whatever the character I want, or the string particularly I wanted to transfer, I write it here. Just below this, I write it here, serial communication. So now if you look into it, in 300 location, in 300h location, the ASCII value of S will be stored. ASCII value of S will be stored. Then 3001 location, E will be stored. That means ASCII value of E will be there. Then 302, you have a R value, ASCII value of R will be there. So subsequently till M and also including this space, the values will be loaded here. So 302 till this point, it's going to continuously, it will be stored onto a memory starting from 300h. So that's just another part of the program. Now, in order to transfer it, in order to transfer the byte, what do we do have? I have a subroutine here. From line number 17, I have a subroutine. What is the subroutine basically? It takes the value from A and loaded onto SBUF. And as you know, once you loaded into the SBUF, the transmission will be taken care, and we monitor the TI bit. Once we transferred the byte, then we clear the TI, then we'll return to the calling program. So from line number 17 to 20, it's basically a subroutine. Now coming to this part here where we have interrupted. So from line number 9. So in order to fetch the address of the first character in the given string, okay, so we are actually it is in 300h, But what we can do by using the label, we can specify the address. So instead of saying 300H, what do? I specify this address my val. So when I say my val, it's basically a 300H location. Okay, then 3001 it will go, 3002 it will go, and subsequently it will be keep going on. Okay, so like that only. So what do we do first initially? Since we are using the DB, that means we have stored our string in a program memory. It's in the program memory. So what do? We are supposed to use this instruction, that is MOVC a comma at a plus dptr. So this is basically a simple data transfer instruction from a code memory. Okay, so now here, so what do we do first? First, we load the DPTR with the address of my val. What is the address of my val? That will be 300H. So DPTR will be loaded with the 300H. Okay, next what do we do? And yes, this will come later only, but I'll tell now only here. This I have used as a counter to count the number of characters in a string. So if you look at it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 characters are there, including space. So I've specified here in hexadecimal 0CH. Okay. Then what do? I clear the register A by using clear A instruction. Now, what is there in A? A will be having 0. This A will be having 0. Then what will be there in DPTR? DPTR will be having the address of my val. It's nothing but a 300H at this instance. So 0 plus 300 will be the new address. So from this address, whatever is there, that will be moved to A register. Okay, so once we do that, now what is there in A register at present? Yes will be there in the A register. So immediately we call the trans subroutine. This trans subroutine, what it will do? From here, whatever is there in A, that is basically a yes character, that will be moved to SBUF. Then it will be monitored here and we will return to the program. When you come to the return to the program, so subsequently for 3001, we don't have a label, but what we can do is we can increment our DPTR. So previously DPTR is what 300. Now the DPTR will become 301. 301. So 301. And next what we do, we need to transfer 12 characters. So to count the 12 occurrence of 12 characters, what do? I use a counter here. So every time when it completes the work, it will decrement by 1. And if it is not equal to 0, then it will come here again. It will come here. That is continue. So continue. So again, what we'll do, we clear the A. Now what will be there in DPTR? The DPTR will be having 301. 301. A is cleared now, so A will be having 0. So 301, what is there? That is E is there. So that will be transferred to A register. Again, we call this subroutine. This will continue to do the work. So like this, what do we do? First, by using this R2 counter, I transfer this once. I transfer the 12 characters once. Then what do I do here? I want to do it continuously. If you want to continue do it continuously, means what we have to do? Again, we have to bring our DPTR to the 300 place. So what do we do? So again, take the control. Once I complete this for one time, then I will take back to the again here. So again place, what do I do here? Again, I reload my DPTR with the first value, then reload my counter here, then counter the A register is cleared. Then again from 300, we will start the work so that we can see that it continually, it will transmitting the value serial byte serial communication. Okay, so now just run this program. After writing this, I built a target for this program. Now I run this. So in order to run this, what do? I go to debug, start debug session, and already have a serial communication enabled here. I just run this program. What it should display? It should display serial communication like that. It should display. So after a while, if you stop and see that, continuously it will display now serial communication, like that it will continue to display. Understand? So any character could be changed. So by using db also we can write our code. Okay, thank you.